Hello, today we are switching to vertex form, and this first example we are going to do using the calculator. So we're given some directions here, and it says use the calculator to find the vertex. So first off, I'm going to just talk about that a little bit. We have here a quadratic. We know it's quadratic because of the exponent of 2. And when we think about a quadratic, we think of the graph being a parabola shape, which is basically a U shape. So somewhere on the graph, or on the coordinate plane, we get a parabola. This point, which in this case, is a minimum value, is the vertex. And that is that point where the slope changes. So here our slope is decreasing, and then at this moment it switches to increasing. And so we are going to find that point from the calculator. So we'll go to our graphing calculator and we'll type in this formula. So I'm at my graphing calculator and I've already hit the y equals button, and I want to type my formula. So we had 0.7 x squared plus 7x plus 15.5. And we know a little bit about this parabola from the equation. We know that because of the a value here that it is opening upward, so it will have a minimum. And we know because the a is less than 1 that it is a fairly wide parabola. But beyond that, we don't know a whole lot from the standard form of the equation. A good option when graphing a generic algebra problem is to use the zoom button and choose option 6, which is a standard algebra window. This gives you a window that goes from -10 to +10 in both the x and the y axis. And we see that this works very well for our parabola because we see the shape of the graph and we see our key point, the vertex or the minimum. So we're going to try to find the ordered pair for this point, and to do that we'll use second and the trace button. Because that is a low point on the graph, that is a minimum, and so we're going to choose option 3, minimum. When we're working with the minimum, it will ask us for a boundary because the calculator is only going to look for the lowest value within our boundary. So the first thing that I'm asked is for a left bound. So I need to move to the left of where my minimum point is. So you can see I'm using my arrow key until I am definitely left of this low point or minimum. I hit enter, and my computerized calculator here puts a line. My handheld just puts this little arrow, and that is the left bound. It's now asking me for the right boundary, so I move to the right of the minimum. And again, I hit enter. Went a little further than I would have needed there, but I just have to be to the right. It asks me to guess, which is not essential, but I know that my minimum is down here somewhere, and I hit enter one more time, and it gives me a value. We can see that the calculator with its pixels has a little bit of difficulty getting this value to be exact, so you might have gotten a -4.99999, or as we did here, a -5.00001. So either of those would round to -5, -2 as that minimum value. So going back, it says use the calculator to find the vertex, and we found the vertex for that to be -5, -2. We had made a sketch of just a generic parabola, but when we saw our particular parabola on the coordinate plane, it was over here, and this is the vertex that went -5 in the x direction, -2 in the y direction. Next it says use a from the standard form. So a is this first coefficient, so this number right here is my a. And then it says plug in the values for h and k. So in order to do that, we really need to know what is vertex form. Vertex form of a parabola is the equation where we have a, x minus h, that quantity is squared, and then plus k. In the vertex form, and you could put a y equals in front of this or an f of x equals in front of that, the vertex is obvious because the vertex is right here as h and k. So this has vertex of h, k. Now k is the easy one because it is directly a match to the ordered pair. With h we have to be extremely careful because the formula has this negative here which is not included here, and so there is a sign change as we move from the formula to the h value. So to write my vertex form for this particular equation, I write y equals, I reuse the a value which is part of both formulas, so 0.7. Inside my parentheses I have x, and then I'm looking here, this is my h, this is my k, and I know that there's a sign change, so plus 5, quantity squared, and then we have either plus a negative 2, or you don't have to do the double sign there, y equals 0.7, x plus 5, quantity squared minus 2. Now, just to verify this, I would like to go back to our graphing calculator and graph this so that you can see that it is truly the exact same equation and the same parabola as we had here. It's just a different format. So, in my y equals, I'm going down to my y2, and I'm typing my vertex form of this parabola. So 0.7 parenthesis x plus 5 end parenthesis, that quantity squared, and then beyond the squared we had a minus 2. And so in the computer version, that first parabola we graphed was blue, this next one will be red, and so we'll take a look at the graph, and we can see that it literally graphed directly on top, and so I don't even see the blue anymore because they are literally the exact same parabola. We just have two different versions or two different forms of our equation. So when we go back here, review, we used the calculator to find the vertex that gave us h and k in the vertex form. We used the same a from the standard form, and that is how we switch to vertex form if we're allowed to use the calculator.